Quadratic inequalities. First of all, can you factorise y equals x squared plus 5x minus 14? So think of two numbers that multiply to make minus 14, but when you sub them together, you get plus 5. So we have y equals x plus 7 and x minus 2. Now we've done that, can you sketch the graph of y equals x squared plus 5x minus 14? The key points are the x-intercepts, where y equals 0. And we can see from our factorised form that x is minus 7 and x is 2. So do a quick sketch where we mark on where the graph crosses the x-axis. Now, hence, can we solve the inequality x squared plus 5x minus 14 is less than 0? So that means where is it negative? Look at the graph. Less than 0 is anything below the x-axis. And the curve is below the x-axis between the points x equals minus 7 and x equals 2. So we can write that as a single inequality. Minus 7 is less than x is less than 2. So the three steps when solving a quadratic inequality are to factorise, to sketch, then solve. Nice, easy steps to follow. Let's have a look at an example. Let's solve x squared minus 6x plus 8 is greater than or equal to 0. First step, let's factorise it. So we have x minus 2 and x minus 4, greater than or equal to 0. Then we sketch it. The key points are 2 and 4. So where is this graph greater than or equal to 0? Well, it's equal to 0 at 2 and 4, but the numbers are less than, when x is less than 2, the curve is above the x-axis, and when x is greater than 4, the curve is above the x-axis again. So there we have two solutions where we write like this: x is less than or equal to 2 and x is greater than or equal to 4. Okay, your turn then. Can you try and solve x squared plus 6x minus 4 is greater than 0? Use the previous example, have a go, pause the video, then come back to check your solution. So we have x plus 10, x minus 4 by factorising first. Key points are minus 10 and 4. There's a quick sketch. It's greater than 0 when x is below minus 10 or greater than 4. Notice when the question has greater than or equal to, in the sign your answers will have the equal to part of your inequality as well. Whereas the other one was just greater than, then this one was less than and greater than. There was no equal to on that one. So keep the signs consistent. Okay, another example for us now. How about solving 3x squared minus 13x minus 10 is less than 0? Okay, as we factorise this one, we get 3x plus 2 and x minus 5 as our two factors. That is still less than 0. When we sketch this, our key points are x equals 5 and minus 2/3. So we pop those on our sketch. And where is it less than 0? This is where it's between those two values. So we can see it's between minus 2/3 and 5. But not equal to because it wasn't equal to in the question. Okay, your turn then. Try and see if you can solve 2x squared minus 5x minus 7 is less than or equal to 0. Again, look at the previous example, pause the video, have a go, and then come back, check your solutions. Remember to factorise, sketch, solve. Factorise 2x minus 7, x plus 1 less than or equal to 0. Sketching that, we get minus 1 and 7 over 2, or 3.5 if you prefer. I prefer fractions, they're exact. And then we can see less than 0 is between the two values, but also equal to them because we want it when it's equal to 0 as well. So it's minus 1 less than or equal to x less than or equal to 7 over 2.